Hello, again here at Chemical Reactions and Quantities. We should be finishing off some of this stuff here pretty soon and getting near the end of the topics that we're going to cover. Mainly today, talking about percent yield. Theoretical yield has been what we've been doing all along. It's the theoretical yield is the amount that is calculated based on the amount of used. Those reactants used could be used in the laboratory before the reaction happens, and then as we know, once we go into the laboratory and start utilizing these reactants, that sometimes the lab or the air within the equipment can change or modify what you actually see. So it is good to do a theoretical yield, and that is finding out the amount of product that should be there based on what you measured out originally. Now, in a problem that's done in class or in this medium as well, it's just kind of the numbers that were given a lot of times, and so that gives that there. And so what we've been doing has been theoretical calculations all along. And then when you think about and envision theoretical calculations, a lot of people would probably just envision people sitting there doing a bunch of math with papers and pencils, and that's essentially kind of what we've been doing, is just that, doing a lot of calculations, paper, pencil, doing it before you actually see it, and kind of go from there. So theoretical yield is something that we will calculate, and it will be important when we're finding out our theoretical yield. And our percent yield comes from that theoretical yield that we find. Now, we also use our percent yield using the actual yield. The actual yield is what we actually find in the lab. The lab or actual can sometimes, and that sometimes can be seen as that, as the actual can be your lab, and the theoretical is your calculated. And so ultimately it's like as if you are finding your grade on a test. On a test, in theory, you should get 100%, or your theoretical yield of all the points possible should equal what you get. Well, taking the test is actually doing the test, is your actual yield. How many points did you actually get out of the test? And that tells you your score out of how many it should be times 100 will give you your percent yield. And that is kind of like, how good did you do? Now, some chemical reactions are going to give you low percent yields based on the reactions themselves, not based on the experiment and or the equipment that was being used. So it's important to note that sometimes we can try to increase or have a very good percent yield, but ultimately sometimes some reactions are just in that nature that they're not going to have wonderful percent yields, and therefore we have to be aware of that. So let's try some out. The theoretical yield for a reaction is 26.1 grams. A student carries out the reaction and collects 15 grams of product. What is the percent yield? Well, like I said, it would be the equivalent of saying the test is out of 26.1 grams, and the student took the test and got a 15 as they produce. What is their grade? Well, that's the same as doing what is the percent yield by saying 15 grams divided by 26.1 grams. And then we would put that in our calculator, just like always. and that would give us 0.575. Multiply that by 100. Now, the multiplying it by 100 usually is very easily done. A lot of students will just pick this up real fast and do it in their head to give the fact that they have 57.5% yield as their product is. Now, we're not looking at what reaction it actually is. We're just saying, hey, this is how we kind of calculate it. Very simple method of doing it, as we've always done. Simple first, and then we get more and more complex as the examples go on. For example, a student goes into the laboratory and reacts 10 grams of silver nitrate with sodium chloride. The student recovers 0.246 grams of silver chloride product, and what is the percent yield given? Now, I will give a little disclaimer. This is an actual student's reaction, mine personally. When I was in college, the first time I did this lab and my quantitative analysis, I had to redo it. As we will find out, it's probably not going to go well. So just knowing that that's a possibility is there. Just like always, identifying what we're given. Now, the problem is that we're actually given two numbers. However, one of them is what came out of the lab. So that's ultimately what I want as well. So when I'm finding these things, I have to identify these reactions as I have two givens. The product that I'm given has to be what I want ultimately. So when I'm doing my theoretical calculations, my want is going to be a given as a product. So you shouldn't be kind of working backwards in these types of problems, which might be beneficial for some people. However, this is the route that we're going to take. The chemical reaction is balanced for us. I'm just going to need to resize this here for us so we can have some room to do some calculations. We're going to need to do the molar mass of our compounds here, and that would be silver nitrate, and that gives us silver, nitrogen, and oxygen. Oxygen is 3. Better erase that. Oxygen is 3 times 15.99. Nitrogen is 1 times 14.01, and silver is 1 times 107.87. And then I can do and go through and multiply a few of these in my head just fine, which is nice. And then I get to sometimes we have to just always double check. And we get 47.97 as my answer there. Add all up together to get 169.85 grams per mole. Now that is going to be different than the silver chloride that I need to find. Silver chlorine, since they're ones, I can just utilize their atomic masses and not need to multiply, and I'll just end up having to add them together to give me what I need. Adding those up together to give me 143.32 grams per mole. Now, just like always, I'm going to start with what I'm given, and in this case, it is 10 grams of silver nitrate. And when in doubt, convert to moles, just like we always do. And I need to use my molar mass of my given to do that. So I add my molar mass of my given. And I can see that my labels start canceling out or equal out to 0. I now need to convert to my moles of my want, which I ultimately want silver chloride. So I need to use the balanced chemical reaction to convert 1 mole of silver nitrate into 1 mole of silver chloride. From there, where did I get those numbers from? My balanced chemical reaction. Those would cancel some things out. I then convert back into grams of, but this more specifically, the grams of my want, and that would be 143.32 grams of my silver chloride and 1 mole of silver chloride to cancel the moles out, and lo and behold, there's what we have. I then multiply across the top and then divide by my multiplication across the bottom to give me, in theory, I should have received 8.44 grams. In theory. Now, when I go into the lab, I found that the student, me, early on in my chemistry laboratory career, ended up getting that as my actual, my theoretical being 8.4. And therefore, I got a very small number of 0.0029. Oh, I'm sorry, I think I have too many zeros in that. Just 0.029. Multiply that by 100 to get it into the correct percentage, and then I find that my percent yield is actually 2.91 or 2.92. Give myself a little bit there. Percent. That's not very good, especially in this lab. My laboratory practices had to improve, and I had to redo it. But ultimately, there is kind of your first glimpse at a full percent yield problem.